Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed some of the numericals of our chapter work and energy. Today we are going to discuss rest of the numericals of this chapter. So we can continue with the same chapter work and energy, and we can continue discussing our numericals. So this is going to be our first numerical. A certain household has consumed 250 units of energy during a month. How much energy is this in joules? So a certain household has consumed 250 units of energy during a month. You know that 1 kilowatt hour is considered as 1 unit, isn't it? And 1 kilowatt hour is 3.6 into 10 raised to 6 joule. Okay, 1 kilowatt hour is 3.6 into 10 raised to 6 joules of energy. So here this household has consumed 250 units of energy. So 250 units is 250 kilowatt hour, isn't it? Because 1 unit is equal to 1 kilowatt hour. So 250 units is equivalent to 250 kilowatt hour. You know that 1 kilowatt hour is equivalent to the energy 3.6 into 10 raised to 6 in joule. So 250 kilowatt hour will be equal to 250 into 3.6 into 10 raised to 6 joule. 250 into 3.6 is 900. So you will get 900 into 10 raised to 6 joule. Again, if you want, you can simplify this as 9 into 10 raised to 8 joule. So this is our answer. 900 into 10 raised to 6 joule, or 9 into 10 raised to 8 joule. Okay. So if you want, you can pause the video and note down the steps. Otherwise, I have uploaded the same in your notes session. Let's discuss the second numerical. An electric heater is rated 1500 watt. How much energy does it use in 10 hours? So you are supposed to find out energy and what all things are given or what all data are given in the question. An electric heater is rated 1500 watt. So power is given. Power is 1500 watt. And time is given. Time is 10 hours. Okay, you need to find out energy. So there is a relation connecting energy, power and time. See, we had studied that power is equal to energy by time. We had already studied power is equal to energy by time, or power is equal to work by time. And here we are supposed to find out energy. So energy will be equal to power into time. Energy is equal to power into time. What is power? Power is 1500 watt. And here we need to do one thing. We need to do some modification. Power is given in watt. We need to convert watt to kilowatt. So 1500 watt. How will you convert watt to kilowatt? You had already studied 1 kilowatt is equal to 1000 watt. Isn't it? So 1 watt will be equal to 1 by 1000 kilowatt. Isn't it? So here 1500 watt will be equal to 1500 by 1000. How much? It will be equal to 1.5 kilowatt. Okay, so here you need to convert 1500 watt to kilowatt, and in kilowatt it will be 1.5 kilowatt. Now we can calculate energy. Energy is equal to power into time, and power is 1.5 kilowatt into time. Time is given in the unit hours. So no need to convert hours to seconds. Even though second is the standard unit of time, here no need to convert hour to second. Why? Because here you are supposed to find out the electrical energy consumed by that electric heater. And the commercial unit of electrical energy is kilowatt hour. So we require our answer in kilowatt hour. So hence we converted watt to kilowatt, but time is given in hour. So we need to substitute time in hour itself. So power into time is 1.5 into 10. That is equal to 15. Then what will be the unit of electrical energy, commercial electrical energy? 15 kilowatt hour. Okay, so this will be the energy consumed by that electric heater in 10 hours. Now we can discuss the next question. Calculate the work done to be calculate the work required to be done to stop a car of 1500 kilogram moving at a velocity of 60 kilometer per hour. So here velocity is given and it is 60 kilometer per hour. You need to convert it into meter per second because that is the standard unit. So 60 into 5 by 18. That is the value in meter per second. And whenever you simplify, you will get 3 into 20 is 60. Now we can consider to be simplified by 6. So 6 tenths are 60. 6 threes are 18. So you will get 10 into 5, 50 by 3. Okay, so 50 by 3 meter per second. Now what else is given? Mass of the car is given. Mass is 1500 kilogram. You need to find out the work done to stop the car. So here we need to apply our work energy theorem. So according to work energy theorem, work done is equal to change in kinetic energy. We are considering kinetic energy here. Why? Because car is moving. So we need to find out the change in kinetic energy. So initially the car is moving with a velocity of 50 by 3 meter per second. Finally the car is coming to a stop because we are supposed to find out the work required to stop the car. So finally the car will stop. Initially the car will move with a velocity of 60 km per hour or 50 by 3 meter per second. So what will be the change in kinetic energy? Change in kinetic energy will be final kinetic energy minus initial kinetic energy. So here final kinetic energy is half mv square. V is the final velocity and initial kinetic energy is half mu square. U is the initial velocity. And we know initial velocity is 50 by 3 meter per second because initially the car is moving with this velocity 50 by 3 and finally the car is coming to stop. So final velocity will be equal to 0 here. So here half mv square will be 0 because finally the car is coming to a stop. So here you will get 0 minus half into mass. Mass is 1500 kilogram into u square. U is 50 by 3 whole square. When you simplify and when you calculate, you will get the final value as 20833.3 joule. The unit of kinetic energy, the unit of work done is joule. So we have calculated the work done, and here again the work done will be a negative value. Why? Because as a result of our work done, velocity of the car decreases and finally it comes to stop, or finally it stops. Okay, so this is the work done. We are applying force in one direction, but displacement is occurring in the opposite direction. Okay, for the time being, we can ignore that negative sign also, no problem. So this is the work done. Just apply the work energy theorem. Now calculate the last problem. Let's discuss the last problem. Find the energy in kilowatt hour consumed in 10 hours by 4 devices of power 500 watt each. So here power is given. Power is 500 watt and 4 devices are there. Each device has a power of 500 watt and time is given. Time is 10 hours. So you need to find out the energy consumed by these 4 devices. So first let's find out energy consumed by one device. and power is given, time is given. So energy is obtained by multiplying power with time, equal to 500 kilowatt. Sorry, 500 watt. So the given power is in watt. We need to convert it into kilowatt. And what is how much is 500 watt? 500 watt is equal to 500 by 1000 kilowatt. So we will get 0.5 kilowatt. Okay, so here for power substitute 0.5 kilowatt, time is 10 hour, then you will get 5 kilowatt hour. So energy is 5 kilowatt hour, and this is the energy consumed by one device. Okay, when it is operated for 10 hours. So what will be the energy consumed by 4 devices? So energy consumed by 4 devices will be obtained by multiplying this with 4. So energy consumed by 4 devices equal to 5 into 4, that is 20 kilowatt hour. Okay, so this is the energy consumed by 4 devices when it is operated for 10 hours. With this, I am concluding my session. Notes of the topic have been uploaded. Please go through it. Today, we have concluded almost all numericals of that chapter, work, power and energy. And we will start with our revision sessions from the next class onwards. So please be ready for the revision. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.